Hi guys, welcome back to my channel. So in the previous video, we have talked about Taylor series and MacLaurin series, and I also introduced you guys to ways that you can find the series that approximate a function. However, today I'm going to present to you guys some common MacLaurin series that will help you to simplify many problems on your calculus exams. So here are the four common MacLaurin series that I want you guys to, if you guys can remember this, your life would be much easier. So the first is the MacLaurin series that approximate the function e to the power of x. So, actually proving this is actually pretty easy. Remember that when we differentiate this function, we always obtain e to the power of x. So it's basically nothing, right? And the formula for the MacLaurin series looks like this. Right? And since we know that the function, no matter how many times we differentiate e to the power of x, we always obtain the same thing, e to the power of x. And e to the power of 0 is equal to 1. So basically, it's going to be x to the power of n over n, the factorial of n, and it looks like this. So this is actually the easiest one to remember. And now let's take a look at a much more complicated function, fx equal to sine x. So actually the proof of this, it's very complex, but I can assure you guys that most calculus exam would not require you to prove it. But just in case your teacher or professor is a little bit, not so friendly towards students and require you to prove that, I think that there are many videos online that show you guys how to do it. But because since this is a really quick tutorial, I'm not going to delve into it. But just remember that it looks like this. It's an alternating series. Okay, you can see here is a minus sign, a plus sign, and a minus sign, and so on. So it's an alternating series, and it starts with x, right? And now let's remember that the number right here and the number that we find the factorial of are natural odd numbers from 1 to infinity, right? 1, 3, 5, 7, 9, 11, 13, and so on. It's very easy to remember. And we have sine x, so we will discuss about cosine x as well, because they always go together, right? And now let's take a look at this. Remembering, I'm not going to recommend you guys to remember this expression because it looks super complicated and really hard. You guys can remember just like how you did with sine x. Remember the friendlier looking one. So just remember that it's also an alternating series because so is sine x. It's an alternating series, and here we start with odd numbers, and here we're going to work with even numbers. So basically, that's going to be the same thing, like x to the power of, let's say, a number a or n, I don't know, over the factorial of that number. And in here we work with odd numbers, 1, 3, 5, 7, 9, and so on. But here we work with even numbers, including 0 as well. So we're going to work with 0, 2, 4, 6, 8, 10, and so on. So that's how you guys remember that. It's easy. So for sine x, we're going to work with odd numbers. For cosine x, we're going to work with even numbers. And remember that our series is our series are alternating when they approximate sine x and cosine x. And now, for the last one, it's actually, well, it looks pretty odd, isn't it? I'm sorry, doesn't it? Okay, that's 1 over 1 minus x. And it's pretty easy to remember. So it's basically going to be, well, x to the power of n. And it looks very simple. Okay, so these are our common MacLaurin series, but how can it help you guys to actually do calculus? And now let's take a look at some examples. Okay, so first, let's take a look at, example 1. Find the MacLaurin series for fx equal to 1 over 1 plus x squared. Well, this one is not that hard, right? I suppose, since, well, so remember that we have this MacLaurin series for the fourth one right here, and now we're going to do something about that. And now, let's let u be, well, minus x squared. So we're going to obtain fx would be, well, 1 over 1 minus u. So that's it. And now the MacLaurin series for that is written like that. It's going to equal to the sum in, well, 1 to infinity, 0 to infinity of, well, u to the power of n, right? That's going to be like this. And that's it. That's basically it. And now we're going to write it out to be 1 minus x squared plus, well, x to the power of 4 minus x to the power of 6, and so on. That's it. Pretty simple, isn't it? Okay, now let's take a look at the second example. Find the first 4 non-zero terms. Okay, first 4 non-zero terms of the MacLaurin series for fx equal to cosine 2x. So we're going to begin with a series of, well, cos x, right? So basically cosine x is equal to, well, remember, we're working with even numbers this time. And, well, it's an alternating series. So it looks like this. Okay, and now we're going to substitute 2x for x, right? So cosine 2x is, well, it's just going to be 2x squared. Okay, it's gonna look like this. And, well, you guys can write it out, but I'm kind of lazy, so well, so now we're going to find the first 4 non-zero terms. So here are our first 4 non-zero terms. There you have it. It's just that easy. Okay, so, well, basically that's what we have for today, and thank you guys so much for watching, and make sure to subscribe to my channel for more videos like this. So it's the end. Bye bye.